My recent trip to Amsterdam for the Electric and Hybrid Convention further reinforced our core belief that wind power is something that we want to design into this new build project. And so in this episode, we're going to be looking at the different options that currently exist for wind-powered assistance on a motor vessel. And this analysis should help us define the path forward in our current design phase. As a lifelong sailor, this is an easy option for me to embrace. However, in this video, we're going to explore the new sail propulsion systems that are currently on offer. But first, let's have a quick look back at propulsion technology over the centuries.
Battle speed, Portator. Battle speed!
Clippers were usually fully or bark rigged. The hull was very elongated and narrow to allow for maximum slide through the waves. This enabled clippers to sail upwards of 17 knots.
17 knots is impressive by any standards for a ship that size. However, the zero carbon footprint came with a high cost in terms of how many crew you had to have on board to do all of the work on these vessels. In the event of a storm or high winds, these sails all have to be reefed. And if one of these crew members happens to fall over the side, in those days, that would be a log entry and an empty berth for the rest of the passage. And risk to crew is one of the criteria that we're going to apply to these new sail technologies as we analyze them. Fast forward to the 350-foot Ocean Co. Black Pearl, which achieves a max speed of 30 knots. It can regenerate electricity while under sail to carry the hotel loads. With about 3/4 of an acre of sail area, which are suspended from 3 masts that are 70 meters or 230 feet high. This is a splendid vessel, and it ticks all the boxes for our new build except for 2 things. So unless you're going to go with a multi-hull, this sort of rig goes on a hull that heels over, and for a lot of people that is just not the way they want to travel, period. Here's a quick visual to support that feeling. These are the gimbal tables on the sail training vessel Corwith Kramer, which is a 138-foot heavy steel-hulled vessel. And they're getting ready for a meal here, and not everybody goes for that. All offshore sailors know that a squall can sneak up on you, and you've got to get the sails down quickly sometimes. So that's going to require a fully functioning power grid and a lot of little electric motors to get those sails tugged in. I'm just going to speculate that an unfurled topsail 200 feet off the deck, hit by a gust of wind in a squall, would probably lay this vessel right over on its side. The scenario of a power outage was considered in this study that was done in 2004 on a diner rig vessel, and the solution cited was to send a crew member aloft with a battery-driven handheld power drill. In the face of an impending squall, this backup plan might take a little bit of time, and you'd also have to locate a crew member willing to go 200 feet up to do this. Commercial operators who are responsible for most of the maritime carbon emissions have been searching for alternative propulsion methods for years, and they've come up with a number of different alleged solutions. This one, which has a sail about the size of a handkerchief, I'm not really going to spend a lot of time looking at. In fact, this is all you're going to see of it before we move on to the next one. Rotors could be an option.
The wind in front of the rotor sail is accelerated as it's dragged in the direction of the spin. This faster moving wind has a lower pressure. Meanwhile, the wind behind the rotor sail slows, causing an increase in pressure.
Not bad, but there are better options out there, so let's take a look at these others. As both a lifelong sailor and as a private pilot, I appreciate the power of the wind and the various ways that you can harness this power. And over the last 5 or so years, we've been able to see some of these new sail technologies actually put into practice. And we can assess their efficiency under different sea and wind conditions, and we can quantify fuel savings over actual ocean passages. For a new build, we consult with our designers and other experts on a selection criteria that will best suit the owner's mission and the style of vessel that we are contemplating, and also our future ship's operational plan, including maintenance and crewing considerations. Our research led us to this vessel, which is a commercial ro-ro ship that travels between Europe and Guyana in South America. On the initial crossings, the vessel was able to save 350 tons of fuel on each passage. And while this commercial ship is unusually sleek and well designed, our vessel is going to be designed more specifically for sail assistance. This system also meets our requirements for being able to drop sails very quickly in the event of a storm or a squall, using gravity in the event of a power failure. There's an option to tilt and stow the rig, and we have the comfort of not being the first users and having a service and maintenance program in place. That concludes this episode in our new build series where we are looking at our sail power options. And this could change over time, but this is where we are right now in our evaluation of using sail assistance as part of the propulsion package. In the next episode, we will either be going with our design process because we're in the middle of that, and that's very interesting, but we're also at the same time looking at shipyards, primarily in Eastern Europe, and these are some of the same shipyards that are building Lursen, Ocean Cove, Fedship hulls, and they're primarily commercial yards. I'd say they're 100% commercial yards, and so that's going to be a very interesting segment as well. So please stay tuned, and we'll be back soon.